All right, welcome to building quadratic models. These are word problems that have to have a variable squared. So we can solve these using our vertex formula. And the other thing you're going to notice is that the one thing that we can find from this is a relative max or a relative min. So as I read the first problem, see if you can find the dead giveaway and what we're going to look for. It says, after the admission fee was dropped, attendance at the Indianapolis Museum of Art began to rise after several years of decline. So that means it was going down and now it's going back up. So it's the shape of our graph. Notice it then says the number of museum admissions in thousands. T years after 2000 can be approximated by m of t, where m of t is 32t squared. That means your graph is opening up, minus 320t plus 975. In what year was the museum attendance the lowest? Okay, lowest means minimum, and how many people went to the museum that year. So here we need to find t, and then we find m of t or the y. You're looking for the vertex. Now, because it said that the museum's admissions in thousands means whatever you find for that, if you will, y value, or m of t, you must multiply it by 1,000. So here, I'm going to go right to my vertex formula. My t is going to be after 2,000, so whatever you get for a t value, you'll add 2,000 to it. So like I said, we're going to go find the vertex. It's a minimum. H will be the number of years after 2000. K will be the lowest attendance. Again, that must be multiplied by 1,000. So I'm going to use my vertex formula. Negative b over 2a. All right, negative 320 over 2 times 32. Wait a minute. Negative from the negative is a positive. 32 can go into 320 10 times. 2 goes into 10 5 times. So there's my h. So technically, this was in the year 2005. So while we're here, let's go find the k value. Using your calculator, we need to go 32 times 5 squared minus 320 times 5 plus 975. Calculator tells me 175. So attendance has to be multiplied by 1,000. So 175 times 1,000 is 175,000. T being 5 after 2000 is the year 2005. So you have to adjust those values based on what these values up here represent. All right, next problem, swimming area. A lifeguard has 100 meters of roped together flotation devices with which to cordon off a rectangular swimming area at North Beach. If the shoreline forms one side of the rectangle, what dimensions will maximize the size of the swimming area? Maximize. Again, we're looking for the vertex. And it's the vertex that's going to help us find the maximum area. So I need a picture of a rectangle. So in blue, this is my shoreline. There's going to be no roping here. What's in red is the roping. So basically, the lifeguard has to use some knowledge here from this class, puts down, anchors it to the shore, swims out, anchors it so many feet out, swims across, puts down the anchor, and it should touch on the shoreline over here. All right, so we'll label this width, and only one length. Again, remember, this has no roping on it. So the area of a rectangle is length times width. Now, we can't have both the length and the width in here, so we have to be able to replace one of these possible values, which means you need to find another relationship between W's and L's. All right? So my rope, oh yeah, that's right, 100 meters of rope. W plus L plus W has to add up to be 100. So L plus 2W equals 100. Easiest to solve for here would be capital L. So let's subtract over the 2W. And then we're going to replace our capital L here with this binomial 100 minus 2W. Now, I know that I don't have the area, but I need to find the maximum value. So this is like saying y equals, and what we're going to do is multiply this w into the binomial. So that's going to give me 100w minus 2w squared. Now, this is my first term. So if I actually rewrote this, it would be negative 2w squared plus 100w. And this is awesome. Remember, maximize means that the graph has to open down, and it's a negative 2w squared, which means it's going to open down. So here again, we can use our vertex. Your h is going to be the w, negative b, negative 100 over 2 times negative 2. The two negatives cancel to be a positive. We're going to have 100 over 4, which is going to give me 25. So that width is now 25. This width is 25. And then hopefully you can look at that. Well, wait a minute. If I have 100 meters worth of rope, and this is 25, and that's 25, that's 50. 100 minus 50 is 50. There's my length. Or taking the 25, plugging it into this W, where L has been solved for, 100 minus 2 times 25, 50, gives us 50. So we found the width and we found the length. That will maximize the area. Now, if they ask for the maximum area, you just take 25 times 50 and find the area of that rectangle. But they were just asking for the dimensions. So 50 meters by 25 meters is my answer. Those are my dimensions. All right, a farmer has 1,200 feet of fence to build 2 adjacent corrals. What are the dimensions of each corral to maximize the total area? Well, corrals are traditionally rectangles. Now, what he's doing here is that he wants one side of the corral to represent a side of both. So this saves on fencing material. You don't want to put a rectangle, leave some space, and another rectangle, because that will take away from your fencing material. He wants to maximize the size of these corrals. So this side is shared between the two rectangles. So here we have width, 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 length, length, length. If you want to use X and Y's, you're more than happy to. If you want to use X and Y's, I would suggest X be the horizontal segments, because that's the X-axis horizontal. Verticals make those the Y's, because again, Y-axis is vertical. All right, so what's the 1,200 for? Again, all your fencing material. Add these all up. 1, 2, 3, 4 W's plus 3 L's is going to give me 1,200. To maximize area, length times width, there's my area formula. So one of these two has to be solved for L or W. I'm again going to solve for L. Subtract over the 4W and divide it by 3. Do not do 3 into both. Leave it as one big fraction. Doing that is going to simplify the solving process. So I take this big fraction, replace that L right there. So this is my y equals, this is my equation, and we could multiply in the w, and you'll see you get a negative 4w squared, so the parabola is going to open down. Now, here's where I can shorten the work by having knowledge of my parabola. It's opening down. All right, so here's my parabola. There's the location of my vertex, which I don't know yet. But believe it or not, I know these two x-intercepts. See, if I take the area and I make it a 0, then w equals 0. That's this point. Then I take this, set it equal to 0, solve for w, that will be this point. Now, halfway between these two x-intercepts has to be the line of symmetry, which gives me the x-coordinate, or in this case, the w, of my vertex. And then I can put that in over here and solve for L. So like I said, we'll take each of these two factors, set them equal to 0. Well, 0 is done. Here, you have to get rid of the division of 3. So multiply 3 to the 0, that's still 0. Add over the 4w. 1200 equals 4w, divide by 4. W equals 300. Now that means this is 0, this is 300. So this x, or in case w, has to be halfway between 0 and 300, which is automatically 150 feet. So that gives me now the x-coordinate of the vertex, or in this case w. So I'll go over to here with 150, plug that in for w, 150, 150, 150, 150 in my diagram, plug it in here, 4 times 150, that's going to give me 600. 1200 minus 600 is 600. Divided by 3 is 200 feet. So all these lengths of my corral are 200. So they wanted to know what are the dimensions of each corral to maximize the total area. 200 feet by 150 feet. If they wanted to know the maximum area of one of the corrals, okay, 200 times 150 would give me this area. If they wanted to know the total area of all the corrals, okay, multiply those together, then double it because you have 2 of them. Next, music CDs. This is going to be an interesting problem. All right, as most listeners download their music purchases, sales of compact discs are decreasing. According to Nielsen SoundScan, sales of music CDs increased from 500 million in 1977 to 700 million in 2001, and then decreased to 400 million in 2007. As the graph suggests, sales of music CDs are being modeled by a quadratic function. So these are like points, and it's definitely opening down. Here's my point values. All right, T is going to be the number of years after 1997. Now, why did I choose that? Because they really didn't tell me, so I'm going to base it off of my first year. So in 1997, that's a 0, and it's 500 million. Then in 2001, that's 4 years after 1997, so 700. And then 2007 is 10 years after 1997. Now we're down to, again, 450 million. That's these 3 points right here. We are going to use these 3 data points to find our equation. Now, one of these points is going to be super special. So let me open up a new slide. I'll put A and B up at the top. My first point, this is the special point you should recognize. 0, 50. This is your y-intercept. So if I put 0 into my equation where I have the y-intercept, I cannot use vertex form. I must use y equals ax squared plus bx plus c. So putting 0 in for all these x's, we'll zero these out. A times 0, b times 0, c equals 500. So we now have this value. Then I'm going to do the same thing with this point, but when I plug this in, I'm going to let 500 be the c when I plug it in. So 4, 700 means 700, that's your y, just like 500 was your y, equals a times 4 squared, which will be 16a, plus 4b plus 500. And what I'm going to do is I'm going to subtract the 500 over to the 700, and I get 200 equals 16a plus 4b. Now, whoops, wait a minute. Before we go any further, notice that all these numbers are divisible by 4. So when you have a chance to make numbers smaller, divide everybody by 4. 200 divided by 4, 50. 16 divided by 4, 4a. 4b divided by 4, 1b. Smaller numbers will be easier to work with. Okay, we have one more point to do this. We got to do 10 and 450. 450 is the y. Put that in. Equals a times 10 squared. That will be 100a plus 10b plus 500. Again, subtract the 500 to the 450. Gives me negative 50. We said that's going to equal 100a plus 10b. Wait a minute, 10b. Everybody has a 0 in it. Let's divide by 10. So this becomes negative 50 divided by 10 is negative 5 equals 100 divided by 10, 10a. 10b divided by 10 is b. So I have the c. I got to solve for a and b. So what I'm going to do is I'm going to take one of these equations and I'm going to get the problem solved for a. So I'm going to take this 10a, subtract it over, excuse me. I meant to say solve it for b, because b is a standalone variable, not solve for a, solve for b. Subtract it over, there's b. And I can take this negative 5 minus 10a, and I can put it into the equation up here for that b. So 50 equals 4a plus a negative, okay, minus 5 minus 10a. Combine like terms, 4a minus 10a will be minus 6a. Add the 5 to the 50 makes it 55. Divide by negative 6. There's my a value. Not the best in the world, but it's based on my work. It's okay. It looks right. Then we're going to take one of these two equations, doesn't matter which one, plug in this a value, and we'll go solve for b. So negative 5 minus 10 times negative 55 over 6 is equal to b. Sorry, need my calculator here. Negative 5 minus 10 times negative 55 divided by 6, close parentheses. Tell the calculator to give me a fractional answer. Okay, 260 over 3. So I have my a, negative 55 over 6. I have my b, I have my c. Plug it into my equation. There is my equation that I want to work with. Now, if you want to double check, whoops, wait a minute, we got to do, no. If you want to double check, type this into your calculators, y, as you see it, graph it, trace it, type in a 0, there's 0, 500, type in a 4 for the x, there's 700, type in a 10 for the x, you get 450. All 3 points exist on that equation. So that's the right equation. Now, using this equation, we're going to go solve for b. All right. Now, since I plugged this into the calculator, I can go solve for this. Now, 2009 is how many years after 1997? So if I subtract that, it looks like we're going to be at 12 years. So I need to go to my window and change my x max to something bigger than 12. Let's call it 15. And I regraph it, hit the trace button, type in a 12, hit enter, and now it says 220. So in the year 2009, there was 220 million CDs that were sold. All right, now, just want to point this out. There's another way to solve these two equations. This was done by what we call substitution. Solve for one variable, substitute it into the other equation. The other technique is called the elimination. Notice how both b's are the same. Subtract both equations. So if I multiply this by a negative 1, that will give me negative 50 negative 4a, negative b. And I line that up underneath. Why did I choose the first equation? Because this a term is smaller than this one. So this is the one I want to make negative. The b's cancel. I get negative 55 equals 6a. I get there faster. And now we have divide over the 6. There's your negative 55 over 6. Again, you got to plug it in to one of your a's. So again, get the b by itself, plug in your a. Again, calculator entry as we had before. To get to b, you have your c. Another way to get to that equation. And that wraps up 11.8.